question 7 of the term 2 control test. So here we go. The reaction of methane gas, CH4 with steam, H2O, produces hydrogen gas. The equation for the reaction is shown below. So even if I'm not sure what section it is, the point here is that I've got a double arrow. That double arrow tells me I'm going to work with equilibrium, and the forward reaction is endothermic because delta H is greater than 0. Initially, we have 1 mole of methane, 2 moles of steam in a 5 decimeter cubed container. When equilibrium is established at a low temperature, the mixture contains 0.3 moles of CO2. Brilliant. And then they tell me nickel is a catalyst. Perfect. First question, define the term dynamic equilibrium. This, of course, is a definition. Now, for dynamic equilibrium, it is when the rate of the forward reaction equals the rate of the reverse reaction. Definition needs to be learned. Okay? Temperature is increased. Use Le Chatelier's principle to explain the effect on the equilibrium. So, increased temperature, an increase in temperature always favors the endothermic reaction. I've already established that the forward reaction is endothermic. In other words, I'm going to favor the forward reaction. So, there we go. So, an increase in temperature favors the forward reaction okay. Therefore, the forward reaction is favored more products are formed until a new equilibrium is reached. I think it was difficult for you guys to realize what that third point was. Most of you got the first two, telling me that the forward reaction would be favored, and because it's the endothermic reaction. Okay. Oh, I should say endothermic here. My goodness. This should say endothermic. I do apologize for those of you who actually do write down while you're doing this. So endothermic, and that's forward. I apologize. Alright, but it says what is the effect, to explain the effect on the equilibrium. So when they want effect, they're also wanting to know product, favor, or you're going to have more product, you're going to have less product, that sort of thing. Okay, it's not just which reaction is going to be favored, but then how does it change, what's going to happen when you get to equilibrium again. Alright, great. So, now we want the equilibrium constant at the original low temperature. I had initial conditions, I've got final conditions, so I know I have to set up a table. Alright, that's not even an option. So, I know I'm going to set up a table. Ratio, initial change, equilibrium, and there's 4 things. Okay, oopsie, let's make that a little bit better. 4 things. Oh, that was even worse, I think. So we have CH4, we have H2O, CO2, and H2. Then we're going to have the ratio, initial, which is in moles. We want the change, which is also in moles. We have the equilibrium number of moles and equilibrium concentration, which is moles per decimeter cubed. Looking at the equation, my ratio is 1 to 1, 4. 1 to 1, 4. Initially, I have 1 mole of H2O, and if I look there again, what did they say to me? 2 moles of H2O, but it means that I'm going to have 0 of this, 0 of that, and at equilibrium, I've got 0.3 moles of CO2. All the information I was given, now I'm going to work backwards, and remember that we add, minus, minus. So I had 0 CO2, I've now got O3, so that's going to be 0.3. Now I use the mole ratio. Okay, 0.3 times 1 divided by 1 ends up over there. 0.3 times by 2 divided by 1 ends up over here, 0.6. 0.3 times by 4 divided by 1 ends up over here, 1.2. Remember, we minus, so it's going to be 1 minus 0.3, 0.7. 2 minus 0.6, 1.4. 0 plus 1.2, 1.2, but we're not done. Over here, I now need to divide by 5, because the volume of my container was 5 decimeters cubed. That's going to give me 0.14, 0.28, 0.06, and 0.24. We're not done. All we've done is find the equilibrium concentration. So we remember that Kc is my concentration of my products, and it's H2 to the power of 4 divided by the concentration of my reactants. And I'm including the H2O because it's steam, it's in gas form. It's not a pure liquid, so I absolutely have to include it. Now I do my substitution. 0.06 times 0.24 to the power of 4 over 0.14 times 0.28 to the power of 2, and we end up with 0.018 without any unit. Okay, biggest mistakes, not recognizing that it was equilibrium, not using the right ratios and not dividing by 5, and then of course setting up the Kc expression, so you need to be careful.